Hi, as Denise said, I'm Rich Mahoney. I'm the actually outgoing president of Silicon Valley Robotics, so John Dolcinos of JBill will be taking over, but I've been involved with Silicon Valley Robotics from its inception. I'll still remain on the board. As part of my work in Silicon Valley, I had this other job as well as the director of robotics at SRI International, where I was managing a group of 60 scientists and engineers working on a broad set of technologies at the leading edge of robotics innovation, doing work for DARPA, commercial clients, and as well as spinning out companies. So during that time, I worked with Kurt Salisbury from SRI, who's back in the corner. Or Kurt, maybe you can raise your hand, trying to act like he doesn't know me, but worked on harvesting robotic applications, and Kurt's now left SRI and spun that out as a company called Abundant. I've actually left SRI as well, and I'm now with a company called Superflex, which is around wearable technologies, but it gives you a sense of the kind of environment that I'm coming from. It's early stage robotics, it's DARPA-style technology innovation with an eye towards spinning companies out and making an impact in the market. So I'll talk a little bit more about some of my views on robotics and how it relates to agriculture, but what I'd like to do is let the panel introduce themselves, and what I've asked them to do is tell the audience why they should care about listening to them for the next 45 minutes. So I'll turn it over to them. So Dan.
Tēnā koutou katoa, ko Dan Bluma hau, no Ngāti Kahungunu Roy. Hello everyone, I'm Dan Bluma and I come from Hawke's Bay, which is on the east coast of the North Island of New Zealand. Like most people here, I wear several hats, and I'll just very quickly explain what those are. I established and run a very small AgTech hub, which has currently got 7 companies working together. They range from startups trying to define their purpose through to established companies. One of them is quite active in the US. It's Altus UAS, and they are selling UAVs here. Their equipment's been bought by CNN to go through the FAA flyover crowds approval program. Others are doing services. My part within that through my consulting company is about bridging, so linking thinking from the farm out, so working from the farm base out towards technologists, researchers, and actually regulators as well. The other thing I'm involved with is I established a charitable NGO in 2003 focused on sustainable cropping through technology, and we're about to run our 14th annual conference on AgTech next month. Part of that, we'll be hosting 24 lead farmers and agronomists from Australia who are coming over to talk about AgTech, precision ag and that sort of thing, and we'll host them for a week through the country. So my focus today is very much on what's in it for farmers and what they need from technologists.
Hi, I'm Geoff Furniss from BBC Technologies. We're a company based in the Waikato in New Zealand, and we make fruit sorting and packing solutions primarily for small, delicate crops. Our specialty area is 40 millimetres in diameter and under. We operate in 27 different countries around the world, designing and building everything from New Zealand. The history of our company is, I guess, we've become slightly unusual. We originally started as farmers. We still have a strong farming connection and operate our own blueberry production in New Zealand. So we integrate the growing methodologies, the packing methodologies with our own technology. So we're very much farmer-led as far as the solutions we put together, and global in context and scale. So we work very hard to try and drive value to our customers that makes sense to us in the industries that we operate in, really trying to optimise the returns and use technology as much as we possibly can to add value wherever possible. So it's quite focused on the end results and how we add value through technology.
I'm Andra Keay. I'm Managing Director of Silicon Valley Robotics. So the organisation that Rich started, I picked up the operations and sorting out what we would do, how we would do it, where we would go, and sat back and watched a really exciting journey over the last 5 to 6 years, which mirrors the transition of robotics from research and out into the real world in a very exciting fashion. I also have many hats. I'm the co-founder of a global robotics research network and a robotics makerspace at a very local grassroots level, and a global robotics startup competition. And one of the things that is a critical part of this transition of robotics out of the research lab and into the real world has been the role of startups and startup development. And Silicon Valley has certainly been the best place to see that happening and to be part of shaping the interest in robotics that's here. And if you detect a touch of an accent, I'm originally from Christchurch, but I spent most of my life in Australia. And I think that gives me a really good perspective on Silicon Valley, you know, what does make it special or different? Because I didn't necessarily think that it had anything that special until I got over here and realized that there is a certain critical mass here that makes things happen much, much faster. And it's becoming an essential part on everybody's journey. It doesn't have to be your final resting place, but I think if you're on a journey to grow, you have to be here for part of it.
So you can see we have a mix of Silicon Valley representation and New Zealand representation. We somehow got an Aussie up on the stage here as well. My goal is to try to go beyond talking about the things that we already all know are happening, and really think about where can this go, and so what are the opportunities, what will be the difficulties in achieving those opportunities, and what will the world look like when we actually get there. So I'd actually like to start with Dan. So I wonder if you could give an example of a success that you've seen in agricultural technology that has surprised you at some level, but in a way that it actually helps you see what the longer term opportunity will be. Like what can the impact be for the technology in this area?
I think the best example of robotics that's been successful is actually just putting auto steer into a standard tractor. And that's really changed the way that cropping happens, and so virtually all the reasonable size cropping farms now don't steer their tractor. And one of the reasons is it's not so tiring to sit in a tractor for 16 hours if it's driving itself, but it also allows you to unlock a whole lot of other potentials. So that's the one that I've seen the most rapid adoption of, the most rapid change. And it's the one that the farmers see a really obvious value proposition from.
So what does that become 10 years from now? What do you think will happen because of that?
I suppose you take the driver out of the tractor and let them do something or other else. But when you've sat on a tractor for quite a long time, you realise that one of the reasons you're on that tractor is so you can get off and clean things on the back of it every now and then when they block up. So robotics has got to put in a lot of systems other than just steering the tractor. You've got to work out how to take that piece of baling twine out of the spinning shaft. So if you have to have someone there to clean the tractor, they might as well steer it at the same time or do something else. So it's not so easy to just throw robots in sometimes if you need people there anyway. The economics aren't just about removing the person. It's about letting the person concentrate on the operation at the back, not steering where the thing's meant to go. So that's one of the things to think about.
Yeah, and I'll come back to that topic because I think we're at an interesting time in robotics where the classic conversation about replacing labor is really transforming into addressing other kinds of labor issues and other kinds of needs.
And another thing which came out is the chief executive of the European tractor manufacturers was speaking in New Zealand a couple of weeks ago, and he pointed out that field efficiencies from machinery have been gained through getting more and more size into our equipment. But we're getting to the stage where the machines are now so huge that soil can't handle them. And so the Europeans in particular are starting to think, how can we go swarms of small rather than one or two ginormous? So if you've got swarms of small and no labour, then you're going to have to do something other than drivers. So there's a lot of work going on, particularly in Europe and in Australia, on trying to work out how to do that.
Okay, so Geoff, you've been delivering automation solutions for a number of years to real customers, having an impact in agriculture. How do you see your business transforming, and what new opportunities do you see? Just expanding what you're doing, or are you actually starting to look at other areas, given your experience, that you'll be able to, and your lead, be able to take an advantage of?
I guess I see us continue to expand and evolve, and I think, so building on some of those other comments, is that the adoption of new technology into these industries is fascinating, because we're starting to see machines support and make decisions and better selections than what you can do with humans. So we end up with a better crop, better opportunities, and more optimization for what a crop can become than would otherwise be the case. So with that becomes a significant growth opportunity, where you're not just displacing labour, but you're actually adding value to the gross crop and what they've produced, all of which can be transferred across other crops and other opportunities.
Mm-hmm. So when you think about how big your business can become, like how is it it's enormous, or do you see it capped and then moving into other kinds of services? What does that look like more specifically?
I don't think enormous is an option, but there's definitely options to continue to grow before we start to need to move sideways into other areas and other areas. I think for us to be able to grow responsibly and continue to add value to our customers, the objective is to drive the return to the customers first and foremost, rather than to chase growth.
Right. Okay, so Andra, and you're, and it's kind of interesting, because usually Andra is the panel moderator and I'm sitting in these chairs, so it's a little bit of a turn of affairs here. But so Andra, you get to see all of the new startups coming into Silicon Valley, all of the fresh faces of people that are saying, "Oh, robotics is really exciting, and I want to do robotics." And then there, what is the difference with people that want to do something in agriculture? What is their background? What is their inspiration for that? And then what kinds of innovations are you seeing, the seeds that are being planted, pun intended, that are going to grow in this to be a big deal in a few years?
Okay. Agriculture is probably my favorite sector for robotics, because I think it combines real technological innovations and improvements, things that we've just reached certain technological tipping points with, and it combines the most important, I think, social impact. If the world's population is doubling in the next generation, the world's food production needs to increase by 70%. And we don't have an inexhaustible supply of land. And in fact, our land is shrinking as we urbanize our arable land. And there are the environmental costs associated with that. So I know that agriculture is a critically important area where robotics can vastly improve the outcomes globally. So I'm always excited to see new agricultural robotics startups. And what fascinates me is that they are across every aspect of the sector, from aerial inspection and possibly spraying and other early manipulation, to ground vehicles that are capable of planting, harvesting, weeding, fertilizing, spraying, and one other thing, 6 aspects of the job there, to robots that are working with animals. And the dairy farm is a classic example of that. But I think the next question is, how much further, what other areas can that go into, to an area that's often ignored, which is aquaponics and robots in the water, to the extension of that, vertical farming, and the impact that robotics and automation can have on every stage of the food supply chain. Soft robotics is an area that really excites me because of the potential there to safely and compliantly handle a very wide range of unusually shaped objects in a way that has not previously been possible. So I think that the field of agriculture needs robots, and the field of robotics has just matured to the point where it's starting to produce solutions that are applicable in the areas of agriculture, and it's a wonderful thing to see.
So Dan, is there if you think about, there seems to be more attention now, there seems to be more expectation. You know, I've been in robotics for over 20 years, and it seems like every decade this is when robotics is really going to take off. From your point of view, coming really from the perspective of wanting to innovate and benefit the outcomes in agriculture, what are you seeing from the technology that's new or different now? Like what's now available that wasn't available before? What's easier? What invention or innovation has occurred that's making more possible from your point of view? And be interested in hearing things that you're seeing, you know, New Zealanders uniquely discover and demonstrate as well, if there's perspective there.
I'm going to avoid that last bit for a while. I think maybe if I just talk about 3 onion farmers that I know and what they're looking for, and they're all very, very different. So one of them is an organic producer. One of them is a highly innovative, very large conventional producer. And one of them is a very old conservative grower who struggles to use a Nokia cell phone, let alone a smartphone. And I spoke to them about robotics, and all 3 of them said would love one, but for totally different reasons. So the organic grower is spending up to $10,000 a hectare on labour weeding onions. And he said if the problem there is actually the workers don't turn up, and if they do, they get bored and don't do the job very well, and they're very, very expensive anyway. So if you could bring me a robot that would go up and down my rows and weed my onions for me, then I'd be really keen to get my hands on that. So it needs to be able to remove the weeds without nasty chemicals, because I don't use nasty chemicals. So that there's a thing there. He can use heat, and a robot can very easily go across and choose to use heat. That's very expensive if you do the whole thing, but if you use the optics to identify the weed and then just blast the weed, it gets your energy costs down and makes it economically quite interesting. The very large conventional grower said, I'd love robotics because the chemical herbicide choices we've currently got are reducing by the year. So every time the Europeans choose to remove another one from the market, New Zealand loses it from its market. And also the herbicide resistance is developing. So while we've got solutions now, we can see an end to that, and we would like to have mechanical weeding options, partly to extend the life of the current herbicide suite we've got, and also to potentially replace that further down the track. And the grower, who's not very much into technology, said, you know, if you could give me a robot, because I grow potatoes one year and onions the next, and I get old potatoes growing up through the middle of my onions and causing me lots of headaches. So if you could give me a robot that wandered around the paddock, found the potatoes, and either put some spray directly onto those or pulled them out, I'd love that robot, please. So what do we need to achieve those things? So rather than what's the technology we've got, that's the problem. So the things which is happening is just the ability to do optical processing. And again, work coming out of Europe, there's work going on in New Zealand, there's some very nice work coming out of Queensland on, in fact, the University of Southern Queensland is quite interesting because they're using consumer optical devices like smartphone cameras or Microsoft Kinect cameras, and the graphic capability of smartphone cards to do image processing on the fly in robotics. So they're able to identify different weed species and choose to apply a different management strategy depending on what the weed is. So they need the optics, but they also need the agronomy and the understanding of weed demography, I suppose you'd call it, to know that in this area that herbicide will kill you, so I'll just inkjet print herbicide onto your leaf. But that won't kill you, so I'll inkjet you with this herbicide, but actually you're probably weed resistant in our region, so I'm going to stop and burn your head off with a laser or whatever. So there's huge sustainability benefits when you're not drowning the entire area in chemicals, and big cost savings obviously as well. The other one is we're getting pretty close with machine vision systems. So the GPS to get the positioning is pretty expensive, but you still need the machine visioning at the end to get the job sorted out. And the robotic manipulation to get whatever you're using in the right place is pretty much there now. What we do still need to be aware of is that farms are very dirty places. And so they might be muddy as muddy, or they might be dusty as dusty, and you've got to make systems that work in very unpredictable, very dirty environments.
Yeah, thank you. So that's definitely a theme that we saw at SRI, the use of more and more commodity component technologies in robotics. And part of what that allows is it does dramatically bring down the price, and that does make it more accessible. But what's also more important is that it makes the technology accessible to entrepreneurs. And there are more people who have background in farming that can now think about starting a business and trying something, because robotics hardware isn't millions of dollars it's almost like going and getting another personal computer as part of your hardware, and you can do some pretty significant things at that scale. Another part of robotics, in a way that I'd like to think about a robot, is it's really the interface between the physical world and the information world. And so I've had a lot of people try to cast robotics as IoT, because IoT is what's hot right now, but it really is about data and information. And I wonder, Geoff, in your work, how much of what you do is measurement and sorting versus how much is collecting the data, and what have you seen the role of data do to your business, and how has it helped your customers?
We actually don't collect a huge amount of data with our stuff at the moment, but I think it is conversations we're having with our customers at the moment. They're starting to understand there is data being generated by these machines. The information coming off the image processing has obviously got value. I think there's a conversation just starting to be had, because I don't think people understand quite what can be done with it, and how they can change their farming practices or their growing practices to really optimise their solutions through understanding that. So it's a two-way conversation. One is of what does a customer actually really want, what is of value to them, and then what can we currently extract. And I think it's trying to match those two things together as a bridge that's being joined at the moment.
I'm sorry, go ahead.
I think one of the things there is that we haven't been doing a very good job of following data up and down the value chain. And the processing company, the fruit sorting company, that's the hub of the data of the whole thing. And from that point, you've got every known quality parameter about your core product that you're selling sitting in one place. And most companies like yours will ditch 99% of that data a microsecond after you've flicked an actuator. So we have problems appearing in storage, whether it be a kiwi fruit or any other product, close to market, and when the problem arrives there, it's extremely expensive to deal with. It's huge cost. But it was generated by a decision that was made on an orchard 6 months earlier. But what we're not doing is connecting the orchard management to the market and the market back to the orchard management. And it starts with the way we harvest the product, that we lose its geographic location information in the act of picking it and putting it into a bulk bin. So we really need to go back to think about how we track the fruit back to the tree, or back to the vine, or back to the bush, or the part of the paddock, so we can start doing some analytics and say that all that fruit that had an internal problem sitting in China came from the wet end of the block, sort of thing. So we can then change the wet end of the block and do something. So at the moment we repeat the same mistakes over and over. So the work that's going on in Tauranga towards robotic harvesting and things, that actually opens up a door to that quite nicely, because you could potentially track where each fruit came from with huge detail and then follow that through. So I think tracking every blueberry is quite exciting, but there's a lot of kiwi fruit, but you can follow those and you can learn a massive amount, and you can add huge value.
So one of the things that you're describing is what I've seen generally in robotics is that people just refer to data as data, but really when you look at a specific application, data really means quality. And what you're really using is that information to understand quality, manage quality, increase quality. And the robotics that I've seen that's more successful in use of data is when they're understanding that the robot is an intervention that can actually guarantee quality, both in terms of the process, but also the product that I've used this phrase before, democratizing quality. You're able to reduce the cost, create efficiency, and provide higher quality goods and services to people through robotics.
Yeah, just following on from that, Rich, It's not just about quality. I would say it's the ability to have actionable insights. It's the ability to really have transformational change when you change one aspect of the application of a technology by an order of magnitude. And we've really just seen 3 examples of that. I think it's quite ironic that we talk about agriculture and precision when we're really just starting to open that door a tiny bit into what agriculture really looks like when you have precision, when you do understand exactly what's happening in one spot over the whole life cycle. And so what that means when you ship something, you don't need to fix a whole shipment, you just need to fix one paddock. What that means when you have weeding and you don't need to spray an entire paddock, you can find those 3 potatoes and then you can laser them. And it can remove your dependence on chemical solutions because you're only having to deal with a few square inches at a time. So it completely changes the paradigm. And indeed with tractors, once you take the person out, the person is still in the loop when it comes to, say, inspection or management, but they don't need to be sitting on the system driving it, and you reduce the size of that system, which means that they will be able to go out on immediately after rain. They will not be so subject to clogging with mud. They will have a whole different set of opportunities, and they will avoid a lot of the current problems. So just by one change, a whole transformation can occur.
There's another thing, which is one of the problems that we've currently got with vision systems is actually also a huge opportunity, because when you're trying to do stuff during the day with changing light conditions and the sun being a real nuisance, and all your sensors keep losing calibration every time a cloud comes past or something, with robot, we do stuff during the day so we can see what we're doing, but robots are quite happy to work at night and just use LEDs with stable light. But that actually opens up a whole lot more opportunities too, because if you were doing robotic field harvesting at night, you're harvesting cold product. And so the field heat's gone, the shelf life will be way, way more extended, the quality of the whole product's changed because you're now working at night time doing that. And I was chatting with a farmer the other night and he said, I'd quite like one of those robots of yours, not that I have a robot. He said, because I could send it out when I go to bed and it can go around doing a whole lot of sampling for me in the night. And when I get up in the morning, it'll be sitting at the door with the answers and I can sift through that data and we can make a decision about what we're going to do during the day. And again, if you do the sampling at night, for a lot of things it's a stable data set, because if you're doing it during the day, with the sun coming up and maximum radiation coming through, there's massive change from hour to hour. So comparing part of the day, the morning with the afternoon is confusing, let alone yesterday and today, whereas at night time it's often a lot more stable. So these problems become opportunities and actually add a whole lot of potential into the system, especially if you can be asleep at the time.
And that's definitely another theme I see with robotics when you're introducing robotics, that that opportunity to really find new value in with that technology. It reveals itself in ways that you don't always expect. So we have a few minutes on the panel. We can open to questions. So I don't know, you'll help.
Thank you. So there was a question, sorry, I can't see Andra, Andra. There was a question that was asked Andra earlier by the moderator, which I thought was very astute, and I don't think you really addressed it, so I would like to try it a second time. And it has, from what I understood, the question was, what type of people do you see coming into the, not just robotics, but ag robotics, and what's unique about them? And the, just to give you some background, the reason why I asked that is, so I grew up in a farm in the Midwest. I worked in Silicon Valley for 20-some years. When you talk about things like pulling unique weeds out of crops and stuff, I've actually had to walk through the fields and pull the corn stalks out of the soybean, just because I know the problems and so on and so forth. So I would like to ask it again, because you sit in a very unique place to see a lot of people come through Silicon Valley. So what's unique about the ag people in robotics?
Okay, I dodged that one because I don't want to overstate it. I've been trying to champion the idea of I believe we've reached a point where there is commodity hardware, there is a whole raft of things, most people like you who are on a farm perhaps have been at college and maybe been at Silicon Valley, there is a different, let's say, generation potentially of people on farms who are looking to technology for solutions. But I haven't seen, I would say, a statistically significant set of people coming from the farm and building the robots yet. But I'm very excited by that possibility, and I see signs of that. And I kind of dodged it because I didn't want to start tooting that trumpet too early. But if I would say there is one thing that I see at the moment, is the influx of people that are not pure roboticists into robotics. And it's starting with people who identify more as software engineers or as entrepreneurs. But I think the success for robotics is when it's people with deep domain expertise. Rodney Brooks has said robotics isn't a technology problem anymore. Debatable. He said it's a business model problem. And I think that is definitely true. It's that ability to connect the real problems with what is technologically possible. What excites me right now is in the last couple of years, I've been seeing what I would call market pull. And that is where farmers, or most usually industry associations, have banded together and said, this is what farmers need. Here are the technical specs. Can we commission research or run a competition or in some way get technologists building something that we actually need? That's really exciting.
Hi. So my question is to Rich and Andrea. The reason I'm asking this question is because I feel of your background in SRI. I'm also a mentor at Stanford. The question is beyond research, beyond vision, beyond mission. The question is about dream. What do you both dream to be, which is impossible, let's put it that way, like, which you think it might be impossible, but you still have that dream. Can you share one thought, each of you?
So I've had really fortunate to be in the middle of a lot of those kinds of conversations, and I'll convey one that actually Kurt and I had around how we think agricultural technology will disseminate, and it kind of relates to some of the challenges too, is that there is one path that you can imagine the current farmers who already are, in the US it's like 3% or 5% of the population, suddenly with robotics technology get to centralize all food production, and then you end up having these massive, efficient, robotically enabled farms, and you can have high quality, but you then end up having issues of very central control over food supply. And my view on robotics is that is a possible stop along the way, but that same technology that will enable that centralization also enables decentralization. And what I envision is having this whole farm-to-table kind of trend, having robotics enable that to where you could imagine, there's municipal water, there's municipal gas, there's municipal apples. You can have a garden in the back of your yard where food is produced in a way that's very sustainable and local. So for me, it does this idea of, a lot of people worry about robots taking jobs and hurting people and destroying us, and I just think the opportunity, we overlook the fact that a tremendous number of people have an extremely poor quality of life. They don't have access to the basic quality that we have in our food and the sustainability in our food, and I think the dream for me is that this will play out over the next, and I don't think it's 100 years, I don't think it's 50 years, I think it's 20 to 30 years, where we just create availability of high quality food to people very local to them.
The bit I think is really cool is actually quite counterintuitive. So we think of robotics as industrial tools that stamp out 200,000 Toyotas exactly the same in a predictable environment, and you're talking about industrialization, of centralization, but to me the robot actually is the thing that's going to allow us to go back to custom fix and allow us to do the optimum management of a crop for the environment which it's in, which is different to where you're sitting, to where I'm sitting, because we're on different soils with different drainage characteristics and different shading and different histories and different nutrition and everything else. So in terms of sustainability, we've been using an industrial model of applying a single treatment across an incredibly diverse crop, soil, everything else, and we've been doing sort of the average on a highly variable thing. And as our tractors get bigger and bigger and we take out more and more fences, we treat bigger and bigger, more and more variable areas the same, and it's kind of dumb. So instead of having 25 tonnes of steel in one machine, why don't we have 5 tonnes of steel in 10 machines that are actually doing custom sampling? They can measure every plant, they can do soil sampling, because you guys are going to turn up with all sorts of neat soil sampling gizmos like Star Trek soon. And we'll know how to do every plant, if you like, custom treatment. So it's this highly industrial method is going to allow us to do totally unindustrial kind of thinking.
One more question?
Thanks so much. It's a great panel. Andra, I wanted to pick up, you had talked about our challenge, the global challenge of having to increase food productivity by 70%. And of course, the vast majority of farmers, 90% of them are in developing countries like Africa, where they face many of the same challenges we face here in California in terms of limited water, the need to lower costs around fertilizers, energy issues, information issues. So my question is, what are the applications of robotics around in AgTech in the developing world? Have you all thought of that?
Many people do think about that, but I think you've hit on a really important point. The farming practices in the poorer areas of Africa are where the United States was 100 years ago. And that's not that far back, but it is a significantly different practice. So the robotics that we develop that are appropriate for Australia and for the US and for New Zealand, each is slightly different, but is going to be quite different to that is relevant to Africa. And so I think it comes back to the question, to what I said about deep domain expertise. And it's a conversation that I know many people in Africa are interested in having as well. It's not something that Silicon Valley answers, but maybe we can enable.
I think Africa's quite a big place, but Zimbabwe is quite a big place. But I think most of Zimbabwe now lives in my hometown. So there was a mass exodus of Zimbabwe farmers to Canada, Australia and New Zealand for fairly obvious reasons. And they've gone from being a massive food-producing, exporting nation to one that can't feed itself. So I question whether all of the issues in Africa are a lack of water, a lack of power, a lack of other things, and how much of it's lack of political stability. And and we're not going to fix that today, but we've got to think what the real issues are. The potential of Africa to feed the world is actually pretty high in terms of a biophysical system. It's got some other systems which aren't perhaps optimised at the moment. And I would say that Africa is the biggest threat to New Zealand. If it gets its act together, we're in trouble.
We have one more question.
Okay. I'm on? Yeah. You've touched on this a lot, which I appreciate, but small-scale diversified agriculture, some of which is being done very well in Africa, produces more food per acre than large-scale monocropping. So, is the robotics, is that going to support and grow that small-scale sector? So.
Yes.
First, I question the underlying figure. I mean, I think the massive increase in productivity in agriculture on the same land with much less labour has been the result of the monocropping kind of culture. But I think it's not environmentally good, period, even if the figures are debatable. And it seems clear that robotics is going to change the scale, and it's going to mean that you can do more in small areas. So it seems to be uniquely set up to enable this small local model. And in spite of the potential issues for aggregated data to create central ownership, I think, I'm with Rich, I think it creates opportunities for decentralization as well. I think we can see a backyard farm economy in our future.
The other thing I'll add is that if you look at how the technology is evolving and what is commodity, what is available. So right now, mobile robotics and mobility in general is commodity. So there's access to drones and other kinds of mobile devices, and for farming, for tractors. So what you're seeing is these solutions that are emerging now are around how do we take this mobility and add some function to it that is specific to the problem you're trying to solve. And that's not going to enable mass integration of robotics into local applications. What's really needed is more general purpose manipulation. And so as you look at robotics technology coming behind mobility is more general purpose arms and hands, and that's being, the pressure there is in the manufacturing sector that has many labor challenges well beyond just escalating wages, and there's a lot of emphasis on creating lower cost manipulators, more dexterous kinds of solutions, and I think what we'll see in the next 10 years is an emergence of more lower cost accessible dexterous manipulation kinds of solutions that become general purpose solutions. Now you can imagine bringing a couple of arms into a farm that can do many of the tasks, and those are then going to allow, as we solve those from the software side, then we'll be able to see them applied more locally and more generically.
I think this comes back to really understanding what the farm's about and understanding the farm system and the social system, the cultural system within which that farm is operating. And so if there's a difference of opinion in the productivity of the land, it's because you're measuring the productivity in different ways. So the Green Revolution measures productivity in tons, I'm in another country, bushels of corn per acre. But when you're in a community that's working in a totally different culture, they measure it in the protein in the medicinal plants, in the weeds are not weeds, the weeds are other crops. And so if you take the value of those other crops and put that all together for the benefit of that local community, they were massively productive, and we possibly didn't understand that. And we're not necessarily listening too well when they're trying to explain that they're now sick and they would like their weeds back. So we need to put our heads into their heads if we want to help them, not tell them to do what we do. And we actually see this back in New Zealand in pastoral farming as well, because what we've done is we've gone to a system that's extremely good at producing milk solids by growing ryegrass. But we then bring veterinary tools in to help the cows, which used to treat themselves by eating the weeds that were part of the pasture. So we've gone to very simplistic industrial models in a biophysical system that's actually incredibly complex. And I think with robotics, with sensing, with data analytics that we're moving to now, we can actually start managing the mess and understanding the mess way, way better. And we don't have to do head-to-head trials with 4-bit replication. We can bring in precision ag trials with incredible levels of complexity and understand and manage those in a way that we've never, ever been able to think of doing before.
Okay, so I'd like to thank you all for your attention, your excellent questions, and please join me in thanking the panel.